Elementary Algebra, Assessment 4, Review, Questions 4 through 7. In question number 4, we're told that we're given the instructions to solve. So question number 4, we have a 5x plus a 5 equals an 8 minus a 4x. The first thing I'm going to do is look at my terms with the variables. I have a 5x and a negative 4x. If I move the negative 4x out by summing it by a 4x, I'm going to end up with a positive value. So that's favorable. It's always favorable to have positive values. So I'm going to move that one. So plus 4x to both sides, and I end up with a 9x plus 5 equals 8. Now I'm going to move that 5 away from the x. So I'm going to subtract it off both sides. This results in a 9x equals a 3. Now I'm going to divide that 9 off the x so that the 9's go down to 1. I'm left with just an x. On the other side I have a 3 over 9. I'm not quite done, however. I want to simplify this problem, so I'm going to reduce the fraction down. I see that both the numerator and the denominator are divisible by a 3, so I'll divide both the top and the bottom by 3, which results in a 1 over 3. Question number 5 has instructions that read, use the multiplication principle of equality to eliminate the fractions or decimals, then solve. Well, I have fractions here, so I'm going to use the principle of equality to eliminate those fractions as instructed before I solve the problem. So I come down here and I end up having the 3/4 times an x minus a 9 over 10 equals a 1/4 plus a 2/5 times x. I'm going to find the lowest common denominator between all of the fractions that are present, and then I'm going to multiply by that number. So I have a 4, a 10, a 4, and a 5 present. The lowest common denominator in this case is going to be a 20. I can find this one fairly quickly because they're really small numbers. I can take this 10 and I see that the 4 will not go into the 10, but the 5 will. So I'll take that larger number and I'll double it. Now I've got 20. 4 will go into 20, as will 5. So 20's got to be my lowest common denominator. So I'm actually going to distribute a 20 through to each one of the terms on both sides of the equal sign. I'm going to multiply it through. So down here you can see I put the 20 next to each of the fractions so that we can see how they'll reduce before we multiply them. I have a 20 over 1 times a 3 over 4. When I look across, I see that I have a 20 in the top, a 4 in the bottom. A 4 is divisible by 4, so I divide it by a 4, as is 20, which results in a 5. So now I've got a 5 times a 3x. Over here, I do the same thing with the other fractions, a 20 to a 10, so I've got a 10 that will go into both. 10 will go into 10 one time, 10 will go into 20 two times. Moving over, I have a 20 to a 4 again, so 4 will go into 4 one times. A 4 will go into 20 5 times. Then I move over again. I have a 20 to a 5. 5 will go into 5 one time. 5 will go into 20 4 times. So coming down and just looking at this, what I've got here left is a 5 times a 3 times an x, which makes 15x. I have a 2 times a 9 to create an 18, carrying down that minus sign to the middle. Carry down the equal sign, and now I have a 5 times a 1, which just results in a 5. And then I have a 4 times a 2 times an x, which results in an 8x. Now, I've completed the first half of the instructions. I've eliminated all of the fractions. Now what I want to do is get the x's to one side and the constants to the other. I'm going to start by subtracting this 8x off both sides. So I'm going to subtract the 8x here and the 8x here. While I'm doing this, I'm also going to get the 18 to the other side. So I'm going to add the 18 to both sides. It's a minus 18 here, so I add an 18. Whatever I do to one side, I do to the other. This results in a 7x plus 0 equals a 23 plus 0. So I have here left a 7x equals 23. My last step is to move that 7 away from the x, and I do that by dividing both sides by a 7. This clears the 7 down to a 1, leaving just the x, equals a 23 divided by 7. Question number 6, the instructions simply say solve. So when we're looking at solving a problem, the first thing we need to do is simplify. We simplify by clearing parentheses and combining like terms. So looking over here on the left side, I see that I have a set of parentheses that need to be cleared. Out in front of these parentheses, even though I don't see it, there is a 1 here. And there's a minus sign here. Before I distribute that 1 through and clear the parentheses, I need to rewrite this as an addition problem. So I'm going to put a plus there. So it's going to be a plus, and this is going to be a negative 1 in here, waiting to distribute through. So it's going to be a negative 1 times a positive 3y to make a negative 3y, or minus 3y. A negative 1 times a negative 2 to make a positive 2, or plus 2. On the other side, I'm going to go ahead and distribute that 3. So 3 times y to make a 3y, 3 times a negative 2 to make a negative 6, plus 3y. So I've taken care of the first step in simplifying, which is clearing the parentheses. Now I need to combine like terms. On the left side, I have a 19 and a 2 that are alike, so I'll combine those to get a 21, and then just carry down the minus 3y. On the other side, I have a 3y and a 3y. 2 positive 3y's make a 6y, and then carry down the minus 6. Now I'm ready to start moving things across the parentheses. So here I've got my 6, so I'm going to subtract my 6y. Subtract my 6y, I end up with a minus 9y. Then I'm going to come in and move the 21 to the other side of the equal sign. So I'm going to subtract that 21 off both sides of the equal sign. So this results in a 9y equals a negative 27. Once I have that negative 9y equals negative 27, I'm going to divide out that negative 9 off both sides. This clears the 9's down to a 1, leaving just the y. And then a negative 27 divided by a negative 9 results in a positive 3. I'm going to follow the same instructions for problem number 7. I'm simply going to solve. So I'm going to come in here and I'm going to clear the parentheses first. So I'm going to distribute this 2 through the parentheses. So once I do that, I end up with a 6s plus 64. Now I can come in and combine the like terms. So when I come in here to combine the like terms, I see that I have a negative 6s plus a positive 6s. Well, these two are opposite, so they're going to cancel one another. I'm going to end up with a 0s. When I combine the negative 55 to the positive 64, I end up with a positive 9. Well, I've got a 0s. This is actually going to result in a no solution, but just so that we can see how it works, I'm going to take this 9 and I'm going to move it away from that s by subtracting it off both sides. So it clears on the left, and now it's over here on the right. So now I've got a 0s equals a negative 9. So in this situation, when I'm looking at the problem, if I tried to divide by a 0, I'd end up with an undefined situation. This means that I cannot work the problem, so there is no solution to the problem.